to the October meeting, seminar series for the OSU Emeritus Academy. We have a great topic this time, in my opinion, and so let me introduce our presenter, Russ Pitzer, who is a California native. He received his bachelor's degree in chemistry in 1959 from the California Institute of Technology, and both his master's in physics and his PhD in chemical physics from Harvard University in 1963. Professor Pitzer was a postdoctoral fellow at MIT and a faculty member at Caltech before joining the chemistry department at Ohio State University in 1968, where he served as department chair from '89 to '94. A great deal of Professor Pitzer's scholarship centers on developing the computer programs for calculating the complex dynamics of molecular substructures. During 1986-87, he was the acting associate director of the Ohio Supercomputer Center, co-founding the center and the Ohio Academic Resources Network. During 2001 and 2003, he served as interim director of the Ohio Supercomputer Center. His father was former Stanford University president Kenneth Pitzer, and his grandfather, Russell Pitzer, founded Pitzer University, one of the 7 Claremont colleges in California. Continuing this academic pedigree, in 2018, the Ohio Supercomputer Center named their newly purchased supercomputer, what else? Pitzer, in honor of his role in founding the center. In 2004, Professor Pitzer received the Faculty Award for Distinguished University Service. He retired in 2008 and currently serves as a member of the steering committee for the OSU Emeritus Academy. In my opinion, Dr. Pitzer has come up with one of the most interesting titles for a seminar this year, Chemistry and the Origin of the Dollar. So let's give him a round of applause, and I can't wait to hear about this.
Thank you. Well, we're relating chemistry to a number of topics, and so we'll try. The automobile industry owes a lot to chemistry. Sonny and Cher, they probably may not have known the chemical symbols for their theme song, but it's there. Okay, in Europe, the first major source of silver ore was found in some mountains called the Erzgebirge, whose name is German for ore mountains. And they're on the border between Bohemia, which is in the Czech Republic, and Saxony, which is in Germany. Okay, the mountains got their name in the Bronze Age because they mined tin there for use in making bronze. But in the 1500s, deposits of silver ore were found in a specific value called Joachimsthal. Means St. Joachim's Valley in English. Joachimsthal is German and Yakimov is Czech. So to locate it, Munich is down here. This is the Joachimsthal. Prague is there, and Berlin is up here. So St. Joachim and his wife, St. Anne, were the parents of the Virgin Mary. They're described in the Gospel of James, which is not in the Bible, but is in the supplement called the Biblical Apocrypha. In our country, they're best known in California under Spanish names, the San Joaquin Valley and city of Santa Ana. Okay, the silver that was mined was used to make coins, And so they're called Joachimsthaler, the H being silent. And the ER suffix means a thing or a person from the location in question. And more familiar is you talk about New Yorkers or Berliners. Berliners are important, are interesting because there are two possibilities. One is an inhabitant of Berlin and one is a pastry. So President Kennedy, during a Berlin crisis, was supporting the Berliners by saying, "Ich bin ein Berliner." And his critics claimed he said, "I am a cream puff." So I consulted a German friend, and he said, it can mean either. You have to tell from the context whether a person or a pastry is meant. So his detractors were exaggerating a bit. Okay, coins with 4 syllables are a little unwieldy, so the name of the coins was soon shortened to 2 syllables in Thaler. And an early reference was in the settlements of the 30 Years' War, which had devastated Germany. Some of the settlements were financial and were expressed in terms of thalers. Okay, Tal is the old High German dialect spelling. H is silent, and it was removed from official German spelling around 1900. But you still see it in names, such as Rosenthal. The Low German dialect, which is the ancestor of English, the word is Dahl. And in Old English, which came from Anglo-Saxon, which was a Low German dialect, there are various words in Old English, see different spellings there. So the Low German word for thalers was dollars. So, but a lot of the business was conducted along seaports where they spoke Low German in general, and so the word dollars was used a lot there. Okay, in the crossword puzzles, crossword puzzle writers have certain habits. They like nice vocabulary of short words with commonly used letters. So they like the word Dale. And so these are some definitions. That have appeared in the Columbus Dispatch. Just Yorkshire blank, fill it in for the crossword puzzle. Or another definition is Yorkshire topography. So the only place in England where the word dale, meaning a valley, is used extensively is in northern England. And the word has been supplanted over many centuries from a French word that presumably invaded England with William the Conqueror. And so here's a map of Yorkshire. So this is to the west where the Irish Sea is. To the east is the North Sea. And here's the city of York. And there's the province or the shire has a backbone called the Pennine Mountains. And then there's these lines here, mean these are ridges to the east or to the west. And in each of those valleys, there's a river. This is the approximate region of Downton Abbey's storyline. Now, as far as I know, they never shot any of their film in Yorkshire. The house they used was in southern England, but they couldn't do the kitchen in southern England because the house there had microwave ovens. So they had to use a set in London for the kitchen scenes. And people would walk up the stairs from the kitchen in London and then appear in the other location in southern England. Well, here's a list of Yorkshire dales opening to the west from the Irish Sea. Note that there's one called Kingsdale, so inhabitants, citizens of Upper Arlington might think it was very nice of the British to name a mountain valley for their shopping center. But with a few moments reflection, they probably figured out that that was about 1,000 years in the wrong order. And then toward the North Sea, there's a Airedale. So you can tell that they bred dogs in that particular area. But you can tell there's a lot more of the dales, mainly on the east. Okay, the city of York was founded as a city on location of small towns in Anglo-Saxon times. It was founded by it was greatly enlarged by the Danes who gave it the name Jorvik. However, the Danes who settled there eventually changed to speaking English over the few centuries. So they changed the spelling of the J to Y. But the British public has a habit of simplifying words. So over the centuries, they dropped the V and I, and York, the city of York, has its shorter name. But think of what we could have had if they hadn't done that. In this country, we would have had New Yorvik City. It just doesn't seem to sound as good. So maybe we owe the British a favor. Okay, another example of the British simplifying words was Henry VIII's first wife. Her name was Catherine. She was from Spain. One of her titles was Infanta de Castilla, meaning Princess of Castile, which was central Spain. But over the years, the British public changed plain Infanta to elephant. So there is a tube stop in an area of London south of the Thames called Elephant and Castle. I mean, the castle is fine because that's where the name Castile came from. But elephant is quite different. Okay, many countries had coins called dollars with various spellings. And the area of Joachim's Tal, where the silver mines were in the border areas of Czechoslovakia, which were the subject of the Munich Conference in just before World War II. So there's lots of history going along with them. And after the war, a lot of the German-speaking inhabitants were forced out of the country. And the lucky ones went to West Germany. So there are stories of very wealthy West Germans packing the grandkids into their Mercedes-Benz and taking them back to visit where they first grew up. Okay, U.S. used the word dollar, as we're familiar with, here in 1792, and it was defined in legislation as having the value of a Spanish mill dollar, which in Spain has various other names, and but is now superseded by the euro. But in the 1700s, the silver miners found another ore. It was dark colored, so they called it pitch blende. And they suspected that they'd found the ore of a new element. So they shipped it to a prominent German chemist who's named Martin H. Klaproth. And he taught chemistry to Prussian artillery officers in Berlin. And he had discovered another element or two previously, which is one of the reasons he was asked to look at the new ore. So he named the new element uranium, because he had friends who had astronomer friends who had just discovered the planet Uranus. So there are other planets that have given names to areas like plutonium and neptunium. He published his work in a small German journal, Chemical Annals of the Friends of Nature. I think that's what it corresponds to. It only was published for about 10 years, but the Ohio State Rare Book Room has a copy. So, Freunde, the friends, the name in the journal, is used elsewhere. It's the first word sung in Beethoven's Ninth Symphony's choral part. But the subject of that choral part is not friends, it's joy, from Schiller's Ode to Joy, which is Freude. So most of the subsequent singing of similar words uses Freude, but there was one important exception in 1989 when Leonard Bernstein gathered an orchestra of European musicians to play Beethoven's Ninth Symphony to celebrate the fall of the Berlin Wall. But he had the singers change the word Freude to Freiheit, for freedom. Okay, Professor Klaproth concluded that the metal ore that he'd been sent to him was an oxide. He tried to reduce it with carbon, as is done in iron ore smelters. And the carbon presumably takes the oxygen out of the metal ore in the form of carbon dioxide. But he didn't know how many oxygen atoms were attached to the uranium. So many years later, some chemists tried to form a chloride of uranium, and one of the products was carbon dioxide. So that had them scratching their heads, because in chemical reactions you can't create or destroy elements. You have to have a nuclear reaction to do that. So it turned out that what he thought was a metal uranium, which had a certain gray sheen, which is a property of metals, was actually the dioxide. Okay, the Bohemian glassmakers in the region where the silver mines were added metal oxides to glass to give it color, and they found that uranium oxide gave it a yellow color, but it had green edges. So So it became popular for decorative glass pieces. So you can still order this kind of glass, and at your next cocktail party, you can turn off the lights and use an ultraviolet source, and the whole piece of glass will turn green. So here's a piece of canary glass, as it's called, for the yellow color. And this is a piece that sits in my office. It was given to me by our glass blower. I used to take students down to the glass blower shop to show them the yellow glass with the green around the edges. But we never bought anything. So the glass blower was diplomatic. He said, well, Doc, I don't have much call for this large diameter glass, but he did use the smaller glass. So he made this piece for me, and we haven't bothered him since. So with a ultraviolet light source borrowed from Professor Hart, which is, you can tell, is over on the right, where it has some blue and purple in it. And the whole thing turns green as advertised. Okay, these color changes were subject of Brewster at St. Andrews University, which is otherwise known for inventing golf. And he figured out that the absorption, light being absorbed, was in the blue, the violet, and even some in the ultraviolet. The yellow was reflected light, and the third color, the green, he called internal dispersion, which is kind of a complicated name. But it shows that he knew that something happened to the light energy after it was absorbed before it was re-emitted, because it changed colors. The study of these uranium compounds was extended by Professor Stokes, who held Newton's chair in Cambridge University. So he studied several uranium compounds, including the glass, and one of his conclusions was that emitted light has lower frequency than absorbed light. But he wanted a new word for this phenomenon, so he took fluorspar, which is one of his mineral samples, which is calcium fluoride. But the interesting optical properties of fluorspar are due to small amounts of lanthanide ions, impurities. So he took the fluor off of fluorspar and the essence off of opalescence, which is the optical property of opals, and he coined a new name which became popular. And 2 generations of the Becquerel family studied the spectroscopy of uranium compounds. But in 1895, Röntgen discovered X-rays in Germany, and people didn't really understand them very well at first, but prominent physicists got up at physics meetings and encouraged other people to look for new types of radiation from any material that had interesting optical properties. So that qualified to Becquerel as one of his uranium compounds. So he wrapped a photographic plate and then put a sample of the compound next to it and put it in his desk drawer. And then a couple of days later, he moved the sample away, he unwrapped the photographic plate, and the image of the sample was on the plate. So that was the discovery of radioactivity. And that's why it happened so soon after the discovery of X-rays. Well, one of his colleagues down the hall was Pierre Curie, who was studying magnetic properties of solids. And he had an excellent woman graduate student named Maria Sklodowska. So in due time, they got married. Well, nowadays, there are rules against faculty dating students, but apparently they were not enforced then. So eventually, after a lot of more work with radioactivity, the three of them received the Nobel Prize. Okay, this is a glass mosaic in a villa on the shores of Naples Bay. And Naples was originally a Greek colony, and the legend was that a seagull or some white-colored bird had led the Greek colonists to this location for their colony. R.T. Gunther is an archaeologist at the University of Oxford. He and a colleague were exploring that they unearthed more of this villa, and his colleague was able to acquire samples of the blue glass and the yellow-green glass in the mosaic. Okay, well, they weren't chemists, so they got two Oxford undergraduates to analyze the glasses. Mr. Shaw drew the blue glass, and he found it was cobalt glass, which is a fairly ordinary thing. Mr. Laws had the yellow-green glass, and when analyzed that, it contained iron oxide and uranium oxide. So in the resulting publication, Mr. Shaw got one paragraph, and Mr. Laws got the rest of the paper. Earl Cayley was an analytical chemist at Ohio State, and he did a lot of chemistry combined with archaeological work. So he read the results and gave a little more definition to what the samples were. Uranium was probably in the form of UO2, and it was just a couple of percent. Well, the Romans were known for using minerals to color glass, and so they probably had found an ore that gave the colored glass, but nobody has any idea where the ore was found. Okay, the uranyl ion, so it's the 2+ ion of uranium dioxide. This is the source of the color, and it's a linear ion, and it's the most stable chemical form of uranium in common chemical conditions. But in a crystal like Becquerel had, it would be surrounded by negative ions. So in electrons in atoms and molecules exist in shells, but each shell has its own energy and symmetry properties and a number of electrons that it can occupy it. So in very simple terms, electrons moving between shells with different energies absorb or emit light depending on whether the change goes up or down in energy. The uranyl ion color was studied by spectroscopists starting around the end of World War II, and many spectroscopy groups guessed the assignment, namely the details of each shell involved. The bottom shell was known to be in detail and was the top one that was trying to be found. And several of these groups made assignments to the upper shell in the transition, and they all got different answers, so you knew that most of them had to be wrong. This is Robert Denning at Oxford University, who did the definitive studies in the late 1970s. He had lots of equipment, modern equipment for that time. You could go to low temperature, use polarized light, and published a lot more detailed spectroscopic information. But the important result was something he could just barely measure, and that's the magnetic moment of the excited state. It was 0. That was enough to define what the upper state was, or the upper shell in the transition. So to treat ions or uranium compounds and ions, you need to use both quantum mechanics and relativity theory. So that should sound to many people like two complicated fields. So you have to make approximations, and so roughly you try and balance them to get the best results for the resources available to evaluate things. So graduate students and I wrote computer programs to do this, and 20 years after Denning published his results, we published our calculated results. And they agreed well in considerable detail. We added a few more pieces of information, but nothing really of any importance. So having more confidence in our methods, then we chose another uranium-containing molecule. It's quite interesting. That's uranosine, with the formula given there. And it's called a sandwich compound because there are two C8H8 molecules, one below the uranium and one above. And the most common similar compound with other elements is ferrocene with an iron atom. Okay, the C8H8 molecules really are most closely described as negative ions. And so the uranium ion in between them is an ion, in this case a charge of +4. The strongest bonds in the molecule are those involving carbon and hydrogen. It's only a weaker bond to the uranium ion. So we can use treat the uranium ion by itself to learn all about the spectroscopy. But it would be the 4+ ion. And since we're treating just one atom or ion, it has spherical symmetry, and which means that the treatment can use angular momentum properties to define things. So the angular momentum quantum number that describes the angular momentum properties of an atom is a script L, which has integer values starting with 0. And the magnitude of the angular momentum is a little more complicated, but that's what the formula is. And it's the actual angular momentum has a constant of Planck's constant. There are two forms of Planck's constant that differ by a factor of 2 pi. And this is the one that's often called h bar. So you ought to be able to make jokes like h bar and grill, but I've never heard a good version. So we found that from our calculations that the transitions were from the second shell with L equal 3 to the fourth shell with L equal 2. And those are the transitions that give the green color. And the intensity depends on the difference between the L quantum numbers. and the most intense transitions differences are 1. So that all seemed to fit. Well, the Department of Energy, before the Cold War ended, had a lot of interest in uranium compounds. So knowing what we had in terms of software and studies of uranium compounds, they hired me as a consultant. And the most powerful computers in the world in those days were Cray mainframes, and they only existed in our country in national labs. So the only faculty members from higher education who had experience with them were those that were consultants in national labs. And so in about 1986, the president of Ohio State University got a call from Bill Coulter, the chair of the Board of Regents, or the chancellor of the Board of Regents, who the regents had decided they wanted to start a supercomputer center. So they hired a colleague, Bill McCurdy, who was also a consultant at National Labs, as the acting director, and I was the acting associate director. Okay, one of my assignments, there were many assignments we divided between the two of us, and some we did it together. One of my things to do was to start a state computer network so that the supercomputer would have access from all the faculty in higher education in the state. Well, I didn't know a lot about computer networks, but you need 2 things to start a network. You need to have contacts in a number of places, and you need to know the technology. Well, in the early days, 2 people who knew the technology, John Highmaster and Mike Fiddler, came to my office and says, "This is what you need to know." And they gave me a briefing, and so we went ahead. But we realized that once the computer network was in place, it was going to get used for a lot of other things besides access to the supercomputer. So I came up with a name that did not mention the supercomputer, just using academic resources. But among the new users of the network was all the librarians at state universities in the state. They decided they wanted a joint library catalog, and this gave them the opportunity to do that. So this is called Ohio Link, and many other uses came subsequently. So that now the network is used by K through 12 schools, hospitals, public broadcasting stations, and local and state governments. So each group that started to use the network would have to put some money into it. So then it would be upgraded for everybody. And so there were several rounds of this. The hospitals use it so that remote hospitals who may not have experienced radiologists can send an MRI or a CAT scan in a few seconds to the Cleveland Clinic, which would have such people. Public broadcasting stations used it to send programs from one to another. Local and state government use it for the state police and many other purposes. The last state government was the last one to join. Now Governor Kasich was informed that the optical fiber capacity that the network owned was vastly larger than was actually being used. And so to upgrade the capacity of the network, it needed to buy routers, which are computers at each node of the network, and sends the messages to the right place. So he found a few $1 million, upgraded the network by capacity by a factor of 10, but then the state government got to use it. So Ornet was actually the first internet service provider, but that only lasted a few months, because as soon as the public was allowed to use the internet, various telecommunications companies jumped in and they hired our one salesman at a much larger salary, and we decided we would not continue in the business. Okay, so that's what I have to say, and willing to answer any questions that you have.
Now, people will ask questions, and I think that microphone's also working.
Not obvious.
Not obvious, okay. So, a question, and then we'll hand the mic back.
Russ, you started talking out in part about silver.
Silver.
About silver.
Mm-hmm.
And the question I want to ask you relates to an unusual piece of cloth called the Shroud of Turin.
Oh.
And I don't want to get into any religious interpretation of how this image might have been formed. But in the history of this piece of cloth, it was at one time in a silver container, silver casket, in a church in which there was a fire.
Mm-hmm.
And the fire heated up the silver casket also. So the question I'm asking relates to if you, as a chemist, and more than just a chemist, a theoretical chemist, could relate this little story that I've told you in terms of this interesting piece of cloth in this silver container, which is heated up, how this image might have formed.
Well, I was going to answer. I didn't think there were any silver isotopes that we could have used isotope dating for. But the chemical conditions, I really don't have much of a clue for what the.
Well, the silver could have been vaporized.
Well, whatever silver compound was there, certainly if the fire is hot enough,
Yeah.
vaporize, and everything inside would have some.
Metallic silver.
It was metallic silver.
Yes.
So then everything inside has some silver in it. But I don't.
Well, you mean silver, metallic silver ions floating around in this casket?
Well, if you're going to get ions, you have to have something to react the silver with, which may be the shroud. Well,
Maybe it had some salt on it.
well, you ordinarily think in terms of oxides, but I don't.
So there's no answer to the question then?
No answer for me.
Okay. All right.
Next,
That's it.
please.
So one of the fun things in your talk was the derivation of the word dale and dales, and which I gather is meaning valleys in English.
Yes.
Some of you may be from the Dayton area, I don't know, but Dayton has a very famous park that I grew up with, which I had no idea what it meant. It was Hills and Dales Park. I knew what hills were, but I had no idea what dales were. And now I do, thank you.
Oh. Well, you can blame it on William the Conqueror for bringing French words. But there are several versions of the word, and in Wisconsin there's a valley, it's called the Wisconsin Dells, which is just a different version of the same word.
Next, please. Way over there, gotta walk.
What's the status of the current status of the supercomputer, the Ohio State supercomputer? is it being regularly upgraded? I remember
Okay.
when it was first installed, but I am not sure that I've kept track of what's happened to it since. And I know it shifts from your topic a little bit, but not from your title.
Well, it's gone through a number of transitions in hardware. At the time it was started, these large mainframes were by far the most efficient. They had special registers for handling matrices. But in ensuing years, the new designs came out, and there were a couple of more versions of these Cray computers. But the microcomputers, like you have on your desktop, those processors developed even faster. As you know from Moore's law, what you get a factor of 2 every year or something, I don't remember the exact form. So eventually, having a large number of microprocessors gave the most powerful computer. And so that's what the Ohio Supercomputer Center has had for several years. And they last 3 or 4 years, and then they're replaced. And so they named them after prominent Ohioans. There were 2 ladies, Ruby Dee and Annie Oakley, and 2 prominent Ohio men, Jesse Owens and John Glenn. But then they ran out of names. So they named the next one after me.
Okay, 2 people over here.
Well, I have a very simple question. If you look at the purity of the gold or silver, generally they will write 0.999. Do you have any philosophical interpretation of that?
0.9. You mean the purity of a sample of metallic silver?
Yes, silver or gold.
Well, it's nice stuff. I don't know. I don't know how much I can add. It corrodes to some extent.
If I were in a business, I will put 100%.
Oh, okay.
Somebody raised their hand over here.
That's an enjoyable talk. You made a comment that you did calculations on uranium to identify the electronic transitions involved. It might be enlightening for all of us if you tell us how much processor time you used in, I guess, the late 1990s to do this, and if you can estimate how fast you could do it today.
Well, we did them in about 1987. No, let's see. Yeah, I guess that's about right. So we used various Cray computers. The calculations themselves probably took less than an hour, but writing the software took a lot longer.
What about today? How long would it take to calculate?
Oh, probably a few minutes. Yeah, that hasn't changed.
Please, to pass the baton on to the right person. Another question, please? We have probably time for 2 questions at most.
There's one.
There's one.
Can you comment on what the most common uses of the supercomputer center now are? Are there weather forecasting or climate or anything, other kinds of applications that people are doing?
Yeah. Well, I'm still on the allocations committee that evaluates proposals for computer time. And a lot of it is for engineering calculations to like modeling the shape of airplanes, the flow of the air over it. Before large computers were available, they could only do it in 2 dimensions, but for some time they're doing 3 dimensions. There's a lot of weather calculations that they use huge amounts of disk space. And they have so much input of temperature and other things in various locations. There is genomics work of matching DNAs from different sources, or just giving the analysis for any purpose. And there are probably other ones that I haven't, not thinking about at the moment.
One final question, please. I expected someone to ask if the supercomputer is used to calculate our pay raises. That's a new question. Somebody, right?
So, Russ, you've witnessed great transformations in computers and computing power over the years. And of course, currently there's a lot of talk about quantum information science and quantum computers. How long, in your mind, until OSC gets a quantum upgrade?
Well, I don't know much about these quantum dot-based computers, but they've actually been in development for quite a while, and proponents are always very optimistic. But I think they've been a little short on results until now. Maybe it'll happen, but I haven't seen it.
Well, I got my exercise just with the microphone today, and so let's give Russ a round of applause for a great